13.2 permutations, starting page 592 in the book. So triangle recursion, that was pretty simple and actually was not nearly the most efficient way to compute the area of a triangle, but we're going to start getting into a little more complex things that are actually, well, it's at times hard to understand, a lot easier to solve recursively. So now we're going to do a class that lists all possible permutations of a string. So permutations being rearrangement of the letters, so eat, if that was my original string, then I have permutations, A, T, E, A, E, T, T, E, A, T, A, E, etc. So those are my permutations, all my options. So we have our permutation generator class, permutation generator with a string parameter to the constructor, and then an array list of strings of all my possible permutations. So we have a test program that runs it. So page 593, permutation generator equals a new permutation generator, given the word eat, array list string permutations, save it as, and then generator get my permutations, and an enhanced for loop for string s, go through my permutations array list, and print each permutation string as we go through it. So again, the hardest part in solving a recursion problem is, what is your base case, or multiple ones? Where do you stop, right? Know when to stop. When do you stop in this case? Well, the easiest thing is to figure out that a single string has its own permutation. So the permutation of the string A is just A. So that's my stopping point. If I can get my string into one letter, then I return that as a permutation of itself, and then I tack that on to all my other possible permutations. So what we have to do is we have to take my word and chop it up. Okay? So if I had eat, okay, I'll generate first all the permutations that start with the letter E. So all you have to do then is rearrange the letters A and T, which is obviously A and T and T and A. Then the question is, I gotta then take A and have TE and ET, and then I have to have T as my start, and I have to have AE and EA. Those are my possible permutations. But to get my smaller ones, to get my base case, what I would then do is I have to take the permutation, in this case, of the letter A, and the permutation of the letter T, and return those, and tack on, which those are just themselves, and then tack on my E at the beginning. Okay, so we're going to generate permutations. We're going to loop through all the positions of the word to be permutated. For each of them, we're going to compute the shorter word that is obtained by removing each letter. So I need to get all my permutations. So first time through, I need to get permutations of the letter E, then I need to get all the permutations of the letter A, and then I need to get all the permutations of the letter T. So I'm going to sequence through, get each letter, and then compute the permutations of the rest of them. Okay? So we construct a permutation generator to get the permutations of my shorter word, and ask it to give us all permutations of the shorter word. So for the first shorter word, I have E, okay, and then give me permutations of all possible combinations of A and T. Then the next time, I'm going to use A, so give me all possible permutations of the letters E and T, etc. So permutation generator equals shorter permutation generator equals a new permutation generator with my shorter word. Array list string shorter word permutations, get my permutation. So if you look at page 594, the top, they have string shorter word is word substring of 0 and I plus the substring of I plus 1. So what I'm going to do is I'm going to go through my word and get every letter except the index that I'm looking at. So the first time through, remember, so a string is actually an array, so this is index 0, 1, and 2. So if I'm going through with a loop, the first time I equals 0, so I'm going to get everything except for that letter. and then next time I is 1 to get everything except for the 1, etc. So there's your permutation generator class, page 594. Let's go ahead and write that. Again, it's a little confusing at this stage. We're not really going to know how it works, but just kind of work through that. And then your extra homework is to go to page 597, thinking recursively, and you're going to work with the palindrome generator. So read through those few pages on page, well, 599 is like 2 letters of it. Into page 600 is the code for a palindrome program. Okay. And the base case in a palindrome is obviously 1 letter. That is a palindrome. It is itself. So I have to figure out how to get my sentence, into shorter form. Again, remember, palindrome is a sequence of characters that is the same forward and backward. So car backward is RAC, but race car backwards is still race car. Okay. So to test if a palindrome, generally what you do is you figure out where the middle is, and you check the first letter versus the last letter. If those are the same, you keep going. If those are the same, you keep going, and obviously the middle is itself. If it's an odd length, if it's an even length, you check both. You have to check, when you're done, you just check both middles against both two middles against themselves. If it's the same, you're good. And as soon as you get a false, the method will kick out, and it's not a palindrome.